All right, this is the 09A video, the introduction to week 9. The topic for this week is going to be work. Now remember, there are assignments this week. There is a homework assignment, which also has your notebook check on it. There is a work activity that is due this Friday. There are going to be 2 labs on that one. Then there's an energy quiz that'll be due Friday, March 26th at 11:59 p.m. Announcements, all the homeworks are open. You'll be able to turn them in late. It will not be graded until the end of the grading period. And all that late homework, labs, notebook checks, and quizzes are going to be due Thursday, March 18th at 11:59 p.m. That way, Friday is the day where they all get graded. Office hours, Friday, 12:30 to 2:30 p.m. Nickname is Cardoza Office Hours. And there's no big question for today. Just as always, I put Sir Isaac Newton up there because he did his best work during quarantine and sort of to inspire us to continue to learn while we are in quarantine. All right, so remember our weekly task list. Just watch those 3 videos, get those codes from it. There's no synchronous classes, but there is a notebook check in replace of those synchronous classes. And there is an activity that is the lab or labs for that week, and there's a homework assignment, which that notebook check is on there. And in each of those videos, there are going to be 2 codes. One will be written, the other will be verbal, said by myself at some point during the video. Each code will be 3 numbers. You will need all the codes in order to move on with the homework assignment. So let's review. Right. So one of the original questions for that was, what limits how tall a roller coaster can get? So when we look at the mechanical energy, right, as it is at a height, it has gravitational potential energy. Now, when it's in motion, it has kinetic energy. Now, you cannot create or destroy energy. Now, as the roller coaster goes up, or as the cart goes up and down, it's transforming that energy from potential to kinetic, but the total mechanical energy does not change. Now, the cart is going to be going the fastest at its lowest point because it's converted that gravitational potential energy into kinetic energy. And it's going to be going the slowest at a high point because, well, that kinetic energy has been converted into gravitational potential energy. Now, that cart will never be able to get over a hill taller than that first hill, because at the top of that first hill, it's all gravitational potential energy, and it can't just create more energy to get to a higher peak. So that first peak is what limits it, unless you have some sort of an external force. So to demonstrate this, we did the over the hill lab, which that really demonstrated the gravitational potential to kinetic and the height of those hills very well. Now, if we looked at a pendulum, right, similar thing, at what points along the path is the pendulum going the fastest? Well, at the very bottom, it's going to be going the fastest because it's converted the most amount of that gravitational potential energy into kinetic energy. Now, it's the points at the peaks, on the ends, those are going to be going the slowest. It's not going to be moving. It's all gravitational potential energy. Now, if I'm looking at something like this, if I wanted to go fastest to slowest, I would just know it's B, C, A, D, just because that is lowest to highest, and I know it's going to be fastest to slowest. Now, it's never going to be able to swing from point D higher than point D because it's never going to be able to generate enough energy to be at a higher point unless there was an external force. So we did do that demo with the bowling ball that showed this, and these are the links for that day. Now, the 08C was about energy. We talked about the roller coaster and and the question for that day was, does mass affect how fast a roller coaster goes? So we did this. Now, this was on a homework assignment. Now I know that the marble is going to be going the fastest at point C and E because they're at the lowest. And I know it's going to be going the slowest at point A because it's at the highest peak. It has the most gravitational potential energy. Now, I know C and E are going to have the same velocities because they're going to be at the same height, right? And if I were going to rank the marble going from fastest to slowest, I'd go C and E are the fastest, D, then B, then A, because I just went from the lower points to the higher points. And without any external forces, it's not going to get higher than point A because you just can't generate that energy to be at a higher point with that gravitational potential energy. Now, we did problems like this where if I'm looking at a roller coaster problem, well, I have all the heights and I can plug the heights in there, and my one of my tools is in front of the velocity. But at point A, it's at rest, so the velocity. Now, at point A, if I know that it's not moving, I know that the velocity is going, or the kinetic energy is going to be 0, and I can calculate the gravitational potential energy. So then I can add all that up and I know my total amount of mechanical energy. And the mechanical energy is going to be the same throughout the track. So it's going to be you can't create or destroy that energy. So I can do the same thing for B. Now notice now it's moving, it has some kinetic energy. So what I did was I calculated that gravitational potential energy, mass times gravity times height, and the rest had to be kinetic energy. And also notice that once I did B, I also filled in E because they're at the same height. They're going to have the same gravitational potential energy, same kinetic energy, same velocity. You can do the same for C, D, and then F is going to be a little different because it does have some gravitational potential energy, but that spring is going to bring that marble to rest and bounce it, and the rest is going to be elastic potential energy. Now it's not stored in that ball, but it is stored in that spring. So now I can use that kinetic energy and the equation for kinetic energy to calculate those velocities, and that is what I get. And like we learned, the mass would not change those velocities. All right, and the spring would get pushed back a certain distance. All right, and that roller coaster simulation that'll show the relationship between gravitational potential energy and kinetic energy pretty well. All right, and then we learned a little bit about why the loops on a roller coaster are oval shaped and not circular. So this video showed the math behind it. Um, Basically, what it is that the oval shapes, they're mathematically designed so the person experiences the same acceleration throughout instead of sudden increases in acceleration, decreases in acceleration. All right, and these are the links for that day. And this is the video 098 written code. I recommend writing this down somewhere. The written code is 818. All right, so what are we learning about this week? This week we are going to be learning about work. Now, this video does a good job of introducing work. And I'm going to give you that verbal code right now. It is 841. I say that again. The verbal code is 841. Now, this is also another one that sort of summarizes energy, work, and power. It's a little, it basically strings all of those concepts together. And then we're going to be doing two labs. We're going to be doing the Destroyed Energy Lab and the Stair Challenge. So it's a pretty fun one. All right, and those are the links for the day. And as always, I'm going to leave you with this. There is too much unknown in the universe to take a break from learning. Get out there and question everything.